again. Okay, good point. Yes. Timothy is here as well. Okay, okay. So I guess we can start. So welcome everybody to the third Madara community call. We are very happy that we have more and more people joining. This is amazing. So the agenda for today we'll start like always by doing a backlog review, and it's an opportunity for all contributors to give an update on their tasks. Then we will talk about the Sharingan testnet and the demo we want to do with Dojo game. Maybe this is new for a lot of you, but we will explain what it is and the goal of this. We have Loth and Terrence from Dojo Initiative that will work with us for this demo. And the last after that, there will be a demo of an actual benchmark of Madara by Lucas, and then we will have a deep dive of the RPC implementation by Timothy. It's a good opportunity to get more familiar with some substrate concepts, stuff like that, and it can be also a great material to onboard new contributors, especially because it will be recorded. So this is something that can be helpful for future contributors. And then yeah, we will discuss about the specific problem, about how to optimize the block projection and have some tasks that can be done asynchronously without blocking the block projection. Or maybe we can, I don't know, how much time do you have, Shoaib? Maybe you want to start with that and then do something else. If you are busy, let me know what you prefer. But otherwise, you can speak about that at the end.
I can wait, no problem.
Okay, thanks. Okay, so let's start with the backlog review. Okay, so this is the backlog. We can do, yeah, each contributor can give an update on the different tasks. Yeah, Matthias, you want to start?
Yes, sure. So at the beginning of this week, started by working on the integration test setup. So mostly highly inspired by Moonbeam on that. The idea is, so there are two things. One is to create the TypeScript augment package, augment API. So like Polkadot, for the ones who are maybe not familiar with Polkadot and the substrate environment, usually you interact with substrate chains using Polkadot.js. But as every substrate chains has their own types and own, basically own API, you want to augment that API. So like add new types and change the existing ones. So that's the goal of the TypeScript API folder that you will see in the Madara repo. And so that's the first thing. And then there is a test folder, which is new. So the test folder is where integration test will lie. Again, it's very easy to run tests. You can just npm install and then write your own integration test within the test folder. And it will basically run a node in the background and on which you can perform your tests, so like execute transactions. For now, we have like basic tests for like declare, deploy, and invoke transactions. But we will have more and more, especially for the RPC. It's a very good place to try things out, and also to try to test compatibility of the existing tooling against existing tooling with StarkNet.js, for instance. Like Moonbeam does this to test that Web3 JS and ethers is working correctly with their Moonbeam chain. And we'll definitely have the similar issue. So yeah, and so integration tests can either run on your local node on your computer, or you can, so there is this ZombieNet folder that's basically still a work in progress in the substrate community, but it allows you to run easily run even network of chains with like multiple validators and things like that, and easily like specify the different parameters like the Genesis config and everything. So yeah, in the end, those two repos together lay the ground floor to integration tests and for further testing in the future. I think that will be very important. So that's what I started working on, and then switch to ERC20 benchmark. So that's what Lucas is going to showcase after, if I'm right.
Yes,
so yeah,
exactly.
you will see. Yeah, and still have some small issues with Polkadot.js to fix, and now we'll start working on RPC endpoints, especially Starknet code.
Okay, so amazing. Thank you very much. Lucas, you want to go next?
Yes. So what I did. So I worked on the. No, I can't remember what I did. Do Timothy first, and I'll check.
You worked on the state diff, Lucas.
Yep.
Indeed, I worked on the state diff. So we had invoked transactions, but we didn't apply the differences in the substrate database. So I implemented that. We lost a bit of TPS, but it's not that bad. And we are really close to having something that's working like we're close to having a decent sequencer.
Okay, and now you are working on the fees.
And now I'm working on the fees. So as Starknet works differently from other chains, so we don't have a native token, we have only ERC20s. So we'll need to implement a palette to handle that, and then use it to handle the fees.
Okay, great. Timothy?
Yep. So my involvement on Madara for the past week has been mostly on setting up the RPC server. So I will do a demo for this a bit later. I laid on the groundwork, and now the idea is that we want to add to the regular substrate RPC server all the Starknet RPC server, so that user can seamlessly interact with the chain as if it was like the Starknet one. And so there is because we use like the wrapper method of maintaining the Starknet chain inside the substrate chain, there's some little tricks to do. And so I will demo this later on. And the second task I worked on was to update our dependencies. So maybe you are familiar with this, but in order to execute code in the substrate runtime, it has to be compiled to WASM. There is basically two runtime execution. One is in the native node execution, so the native CPU of the computer you are running your node on, and the other one is the runtime, is in WASM. The first one is the one which is executed by default if everything goes well, but it's actually optional because the second one in WASM is the fallback one, who always has to be like up to date and is the core one. So it is a really important one, but we use the first one, the native one, when we have the opportunity.
Okay, yeah, we'll explain a bit more about that. The fact that we have two kinds of blocks. We have the native substrate blocks that you can see there. And for each of them, we have one wrapper block that will represent this actual Starknet blocks. And for example, here, this is Moonbeam, which is a parachain on Polkadot that is Ethereum compatible, though, so it has all RPC endpoint, etc. So here, this is the equivalent of an Ethereum block, and this is what we have. We also use the same technique to represent Starknet blocks. So we have the substrate blocks that is very simple. It has a few fields. And then we have the testnet blocks that must be compatible with the existing blocks. And we have this compatibility through the RPC layer, but Timothée will talk about that later. But yeah, okay. Thank you, Timothée. Ben, you want to go next? Okay, I'm talking about Ben working on the global state root computation. Yeah.
Okay.
This one. Yeah.
My English is not that good, so but I can hear you. I can know you what you mean. Now I encounter some problem about first Lucas told me the current problem is we should store the our state tree in the parity DB, I think. So when we need to update the calculator node calculator the we can reduce the time of the storage root calculation. So we can produce the block more quickly. But as you guys mentioned in the Telegram, the calculation of the in the palette is cannot be parallel. So we need to do it async in async function like that.
Yes, exactly. Yeah, but for your PR, for your pull request, you don't have to wait this asynchronous part. You can submit this one in a sequential manner. We will merge it, and then we will work on the parallelization of that. But this is not a blocker for your pull request, so you don't have to take this into consideration for this pull request. Does it make sense?
Okay. Yeah.
Oh,
I got
okay.
you.
Okay. Good. Thank you.
So I
yeah,
think
go
that I need to find a way to store the state tree and the first. No.
Okay.
Yeah.
Nice.
I'm working on this. Yeah.
Okay. Sounds good. Anyone else want to give an update about any task? Otherwise, we can move to the second part of the agenda, which is about the goal of running a public testnet and running a Dojo game on top of it. So the idea would be to have a public testnet where we can deploy some gaming contracts, but I will let Terence and Love explain more about that, about the goal of that, because it's new for a lot of people here, and also an update on where we are at and what needs to be done in order to achieve this goal.
Hey, good morning, everyone. So the state of Dojo, things are moving along pretty well. We just cut our first alpha release. As far as like the things that we landed this week, we've been mostly focused on the migration script of actually deploying the worlds. We're currently doing that against DevNet. And excited to move that to happen against Madara because the DevNet is really slow for us. We haven't made like significant progress on the game itself. I think we're probably gonna, like we've been discussing, just taking this what was a previous demonstration of a fully on-chain game on top of the OP stack called OP Craft that the MUD team built out. And since our smart contract interfaces are compatible with the MUD networking stack, we could potentially use that to demonstrate fairly quickly, like with relatively low effort, a game running on top of Madara. So that's currently the thinking of like the target. And then we've been making a little bit more progress on the client applications like SDKs for interacting with Dojo games on chain. But I'll let Love talk a little bit more to that.
Okay, thank you.
Yeah, just to follow on from Terence, I think I mean, this week we will push ahead, figuring out the exact game, what it's going to look like. From the client side, I mean, it's still pretty early days, but yeah, it's moving rapidly. So I think I think in the next week we should have some kind of interaction in the client, and yeah, and as Terence alluded to, we'll try to just leverage an existing game and just connect up Dojo just for the path of least resistance. So it sounds like everything should line up quite nicely with the way Madara is going as well.
Okay, very cool. Okay. Okay, so I guess we can move to the demo of the benchmark. Lucas.
Yes. Give me a sec. Okay. It's probably gonna be a bit small. Can you all see something?
Yes.
Okay. And so here I'm building Madara, and then I'm gonna start the benchmark. It acts a bit weirdly because it selects like random accounts from the config, so it can select like twice the same account. And if it does that, then there will be nonce issues and it will fail. So we'll have probably to restart it like a few times, and then we'll be able to start the benchmark.
Yeah, for this, I think one quick win would be to add many more accounts to reduce the likelihood of having nonce conflicting issues.
Yeah, or find a way to not select it randomly.
Yeah.
It's surprising. Oh shit! I increased the block. I reduced the block time by a lot.
Oh
So,
yes. What is this block time? Not even
no,
100
it's like
milliseconds.
100. It's 100 milliseconds.
Okay, it's a bit too short. Yeah.
But yeah, but still it works, and
Yeah.
I'm gonna go in the Explorer. Yeah, you won't see that.
No, but can you do it with a 6-second block time to have something more relevant?
Yes, I can.
Because I guess the overhead of the consensus will be too big compared to the time for the execution.
Yeah, maybe. So but I'm pretty sure we had a decent TPS even with that.
Really? Okay.
Yeah.
Interesting.
I mean, we're a single node, so it doesn't have to communicate with like all those things.
Yeah, sure. But even if you take 10 milliseconds for the consensus part, it's 10% of the block time. So
Right. Right. Okay. Okay. And now we can see that we have all the extrinsics. So here we have like 55 transactions in the block. It's quite slow, actually.
yes.
Yeah, it's weird.
Okay, yeah, it's very weird. You did it 1 hour ago, and we were at 360 transaction per block, which is 60 TPS basically.
Yeah, maybe I'll just need to
Turn it on and off.
maybe. Maybe, but it's not that big of a deal. I mean, at least we have something that works.
Yeah, we did it multiple times.
It's supposed to
last few days.
be quite consistent, but
Yeah,
for
it
some
is
reason
actually.
it's not.
Yeah. So the current state, mostly we are at 60 TPS, 60 ART20. And this is quite good because when I posted the first benchmark and the video, we were at 76, but now we have more features and we are closer to something real. For example, last time the first one, there was no state update. Like basically the storage was mocked. Now we also have the processing of events. So maybe you can show some events.
Yes. So we have the events here. And we're also committing on the events and the transaction. Right now, like to have a real benchmark, we would need the state root. And that would be almost it, I guess. But yeah, we're close to something complete block-wise.
Exactly. So Elias is asking what is a reasonable goal for TPS for testnet. So for the one that we want to launch in a few weeks, hopefully something like 50. We don't have, obviously it's not a long-term target at all. But to do some optimization, we will need, the first thing will be probably to switch from the blockifier to StarkNet in Rust. We haven't mentioned it, but basically, we in Madara we integrate the blockifier, which is the component that runs the signature verification and state root. We don't have them in this one as well, so we'll likely decrease again a bit. This is why I'm saying 50 TPS for the testnet in few weeks, exactly. So we integrate the blockifier, and the goal of the blockifier is to actually take the transactions, take the Cairo VM in Rust, execute the transaction. It also has the logic of the syscall of StarkNet, and then it executes the transaction through the Cairo VM, and it generates the state diff. And then we take the state diff and we apply them to Madara storage, and we also retrieve the events and we emit substrate events for each StarkNet event. We are waiting for the benchmarks from Lambda class, but if StarkNet in Rust is more performant, we'll likely switch to it. Then, to be honest, we haven't started at all the optimization track. So there are, again, a lot of stuff we can do to improve. For example, we have some overhead in terms of how the storage is handled and how we communicate with the blockifier, because basically the blockifier has a concept of cache state. And basically, we don't have a native integration, so we have some kind of overhead there when we communicate with the blockifier. And also we have a lot of conversions of types because each library has its own types. So hopefully we can also work on that to improve the performances, and then investigate more hardcore optimization. And also this benchmark is on a local machine, but to be honest, surprisingly, the MacBook M2 Max is incredibly powerful. We don't have the same performance with even bigger machine on AWS, which is very surprising. And by the way, Shoaib, this is also something I wanted to ask. What's your experience about the optimal machines for running a substrate node? If you can give a few words on that, that can be also very helpful. But surprisingly, we have the best performances on the local MacBook M2 Max. Yeah.
Sure, you want the comment now?
Yes, please.
Right, so we are using the standard reference hardware for all our nodes and for benchmarking as well. largely the performance depends, the performance consideration is only on the basis of reads and writes. And since you're doing a lot of computationally heavy things, I am surprised that you're not seeing a performance uplift by going with something that is that has a faster processor or with more cores. But that's probably because of the kind of computation you're doing and exactly what are the nuances there. Validators on Polkadot, however, are using beefier machines, and I'm not sure what the specs there are, but maybe you could just use those and see if that helps.
Okay. By the way, another question related to that. It's true. Like on AWS, we tested on a machine that has twice as much cores, and surprisingly, they were not used almost at all. This is something we were surprised about. There was almost no benefit of having all those cores, which was a bit surprising because yeah.
Is that are you doing everything in the runtime? Because the runtime is generally it's on a multi-threaded computation. So unless you have something that is that has faster cores, I don't think it, more cores will help you than less.
Okay, makes sense. This is exactly what we do. We do everything in the runtime. Okay, so exactly what we will talk about later about moving the global state of computation to the client side. This is maybe something to generalize more and having much more stuff done in the client side, right?
Right. You want me to tell you about that now?
Oh, yes, go ahead, because this is related to that. So, yeah, I will explain first the problem, and then you can go explain. Okay.
Sure.
So the problem we have, and this is also a problem on the actual public StarNet, is that the computation of the global state root is very heavy. It's actually something like 30% of the block production time, which is a lot. So an idea for the future is to, in the block N, include the state root of the previous block, N-1. But for that to be helpful, we will need to make it an asynchronous task done in parallel of the block production. So what we want is in the process of the block production of block N, we have the computation of the state root of block N-1 that is done asynchronously in parallel, and the actual block production starts and it executes transaction, etc., etc. And before finalizing the block, the idea would be to retrieve the state root that has been computed in parallel and include it in the block header. So this is the current problem. And our question was how to do that, basically. Because in a palette and in a runtime, like Shoaib said, everything is sequential. There is no parallelization. So how to do that? So this is the problem. And now, Shoaib, you can explain how to do that with Substrate.
Right. So you can do that fairly easily because the block production, even though it technically happens in the runtime API is queried. The client part of the node is what actually orchestrates the entire process. It picks the transactions one by one, executes them until the timer runs out. So you can always set it up such that you can wait till whatever asynchronous computation you require to be done completes, and then wrap up block production. And then you can finally either put this in the block header, which I think is fairly painful to do. So you can just add it as an inherent, and that should work just fine. There is a slight caveat though. I'm not sure exactly what your intention is around the whole thing, but if you're moving this from the runtime to the client, then you lose the security and verifiability of the runtime. So when you have it in the runtime, every node will run it implicitly and verify that what you have done is correct, that the straight root computation was correct. But if you move it to the client, then you will explicitly have to ask each node to do the same calculation for themselves, and then sort of raise an issue whether it is on chain or off chain, that some computation is incorrect, and then have a way to undo it. So that's something that you'd have to keep in mind.
Okay, interesting. Yeah, makes sense. Makes sense. Of course. Yeah. One thing to mention is that actually the usage of this global state root in the block header is kind of limited. It's actually mainly for light clients because there is no usage in terms of security, etc. Because everything is settled on the layer one. So we don't really need the state root for the life cycle of the chain at all. But it's true that it's helpful for light client to have some state root because we, like for example, what we do on Virus, the ability to use storage proofs and verify them against a state root. So yeah, because an option would be to even say let's remove it completely, but we don't want to lose this powerful feature of having like client that could use storage proofs with that. Yeah, okay, interesting. Yeah, okay. Yeah, Glim, you want to say something?
Yes, sorry, you can hear me? Yes.
Yes.
Yes, it was about this shop just talk about, because from my recent research in Substrate, and I'm new to this, but I just have a question, and Timothy talks about it too. So today in Substrate, you have two runtimes, the native one, which is based on Rust, and the WASM one. And the WASM one is more limited in terms of functionality and how it works. So this is what, and I don't know if it's something possible, but Shop talked about running something in the client, which is also another layer of how Substrate is built. So my question here is, when you talked about optimization and speed, the runtime of Rust today, you are using the runtime of Rust, or you are using the full WASM runtime today from Madara?
So by the way, yeah, so by default, and correct me if I'm wrong, Shoaib, that by default, if you have the code, everything will be run in the native code, actually. The WASM part will be run only for when you do an upgrade and the node does not have the code. Is it correct, Shoaib?
Yes, that is largely correct. So there is no technically a very a difference between the native code and the WASM code. It's just the same WASM code run natively. So if the node already has the WASM code, it's running on the same version, it'll just run it in standard, and that's how you get the performance uplift. So probably why you're asking me this is perhaps the node can run it in native instead of in WASM, and that could that could very well give you a performance uplift. However, if you're moving the whole thing out of the runtime and into the client, then client of course runs in your standard environment. So there is no concept of WASM versus native there. Everything runs on native Rust. So yes.
Yeah,
okay.
Yeah, exactly. And it comes with, as Shoaib said, security risk and non-determinism execution, and yeah, like that.
Because there is discussion in Polkadot, and I think we just need to include this. They wanted to remove the native runtime because today the WASM runtime is the only source of truth. So because it is on chain, which is not the case of the runtime that is native. So I think it's just something to keep in mind, because it means all the optimization that can be done in the native runtime perhaps one day may disappear. I don't know if Shub, you agree with that, but this is something recent in the Polkadot community.
Right, I have not heard about that particularly, but yes, it is completely conceivable that they might just remove it later on.
Okay. Nice. Yeah, Paul-Henri, you had a question, or someone from your side?
Yeah. So indeed, definitely, Pierre, we made some research on Virus on this. So using Substrate Connect to be able to add this. So we are doing right now this research. So maybe later Pierre will be able to talk a little bit more about it. He also made a presentation about it during the last Virus community call. And also definitely about the proof that Abdel, you were talking about. I think that for Virus, it would be really interesting to have it and to enable, as you said, instant syncing And this is definitely something that we have on the roadmap in Beerus, and that we think could be really, really interesting and really important for the Beerus project, especially because we think that it could be a differentiating factor and could be a very big leverage for Beerus to get mass adoption, and also like just in the world of like light clients, it would be really edge tech, you know. So everybody I think would be pretty impressed if we're able to add this to Beerus. So I think it could be good for the ecosystem to keep it inside Madara.
Okay, good, interesting. Yeah, thank you. Yeah, so before jumping to Timothée doing the deep dive on the RPC part, Lucas fixed the problem of the benchmark and wants to show that it's not bullshit and that we actually can handle 60 TPS. So please go ahead, Lucas, and share again. Can you share like you did last time, because it's too big?
You're muted.
And you're muted, yes.
Okay, so yeah, so we started the node in release mode, otherwise it's super slow. And then we started the benchmark. As I said, there are nonce problems because it selects randomly the accounts. But hopefully we'll have, yeah. And now we can check in the next block. The next block here. We see that we have like 30,
which is 64 TPS, yes.
Yeah, so
Nice.
like it's, yeah, release mode is a bit different.
Obviously with the release mode, this is not the same story. Okay,
yeah,
good.
but like we see that we have a lot more TPS than the current startnet, and it's just on my machine, so maybe on a more powerful machine it would be better.
Yes.
All right. So
nice, thank you, Luca. Yeah, Timothée, go ahead for the masterclass.
Hello. Can you all see my screen?
Yes.
Yep. Okay. So what I will do is just go through all the crates I added in order to create the RPC client.
Please, Timothée, maybe you can do it or I can do it, but before jumping, maybe a quick introduction of substrate architecture in general, sure. Because yeah, I can do it or do it if you want.
I will. Okay. So the idea is that mentally, a clear distinction you want to have in mind is what is the runtime and what is not the runtime. So the runtime is the computations that will be executed. Somebody else is sharing the screen.
Abdel,
yes.
with your screen.
Yeah. It's on purpose. Yeah.
Okay. Yeah. So the runtime is the part that is considered like canonic to the chain. It will be it will update the storage, it will create the block. So basically it's a wall layer, like it's kind of the Ethereum virtual machine. So it fulfill like the same role. And then you have everything else, which is the client that will do like transaction whispering, consensus, having a RPC client, managing the storage, also those kind of things. And when you execute something in the runtime, it has to be compilable to WebAssembly, and it will interact directly with the traits defined by Substrate in their framework. On your client, you can do whatever you want, and just it's not part of the consensus. That's the
exactly. One cool thing is that it is heavily configurable and flexible. So that means that all pieces, basically, you can take them as is, or you can define your own one and, as Timothée said, implement some traits. But yeah, you have already some monitoring, everything, and you can take them as is or implement your own custom modules. Yeah.
So the architecture choice we did for Madara is to have this wrapper block model. Is the idea that every block contain inside its runtime a StarkNet block. So the way we did this is we created a StarkNet palette, which is there in palette StarkNet. So a runtime, substrate runtime is a collection of palettes that present some extrinsic to be called and that are also able to interact with one with each other. So basically, really basically, the way it works, you define a config, some hooks, some storage, which are data model, which will be stored on chain. So it's the same idea as the StarkNet storage. So it can be value, map, or map of map. You define some errors, some events.
Timothée, just to check, you don't have to rush, so we can even go further the 15 minutes. So maybe just take time to explain each concept, because this is very important to onboard new contributors. I think this content can be very helpful. So, yeah.
Sure.
Yeah.
2 seconds, because, okay. Okay, so I will go back to this and we are going to do it more quietly. So when we are building a palette, we are using some a core macro, some macro provided by the substrate architecture. So where it is here, this is the core macro, frame support palette. So you put it on top of a module and it will generate like the whole palette architecture and derive a lot of things based on the code you put inside. There is like this core macro, which is really simple. It just say, yeah, this is a palette. There is config. So config, the config make your palette modular. It allow different runtimes, so different blockchain to use and reuse the same palettes while injecting custom value and custom API, custom structure.
Behavior.
The idea is that here, as an example, with the get is a constant. So the palette will be built when run in a blockchain with a state root, which is U266, which is given by the specific runtime and blockchain you are choosing. And those other types, there are traits. So this type, actually here, it's a trait. So the blockchain can choose to pass as an argument absolutely anything that implements this trait. So it can be an object. Here it's something that can hash. But the funny thing is that you can implement traits on palette, because palettes, thanks to those macro, become a type, and you can implement a type on a trait. So you can also inject palettes in other palettes. So that's what we call loosely coupled palettes. Okay, any question on this? It's good. So the way substrate works, there is like start of a block, you receive a lot of transactions, you process them sequentially, you update the storage accordingly, and then at the end of the block, you wrap it and hop, it's a new block. There is a few hooks that exist. The uninitialize, unfinalize are the main one. So this one is executed before any transaction, and this one after all of the transaction, okay? And there is a runtime upgrade is when you do a runtime upgrade. So the one really interesting thing with Substrate is that you can update your chain without doing hard fork. So you don't have to hard fork the chain each time you want to change something. Like, let's say you want to add a new pre-built to the Ethereum virtual machine. I guess you will have to hard fork Ethereum in order for the new node to use the Ethereum virtual machine, the new version. On Substrate, you don't have to do that. You can have a runtime upgrade. And the good thing is you can also govern those runtime upgrade from the blockchain itself. So you can vote on chain. And when a threshold of vote is reached, the next block will be automatically updated to the new version of the runtime. And so there is no censorship on it. It's not like the community will vote and then and nothing will happen. It's in the code. It's really like code is low at this point.
Just to add a comment on that, we had some recent events that show how important it is. Because, for example, with the Arbitrum drama, the fact that there was a vote, and actually then they said no, it was not a vote, and they went against the decision. So with this kind of system, you can enforce it on the code level.
Yep. Yeah, I saw you.
There is a question. Go ahead.
A question? Yeah, go ahead.
Yeah, there is a question in the chat. Why would you want to create loosely coupled palettes?
Yeah. So the funny thing is that here we can see like the two type of way you can coupled palette. Basically, this one, it's hardly coupled with the frame system palette, which is the basic palette of all runtime substrate chain. But I can add other here, and I can say, okay, I want to use the palette balance config. Okay. So now the idea is that this palette cannot work without the palette balance being also a part of the runtime. So I will have to have like the whole palette balance. If instead I create a type like this, balances, and I wanted to implement the trait balance. Yeah, here is the trait. I can inject in this palette any other thing, mostly palettes, that implement the trait balance. So this basically make my code reusable by other people in the ecosystem and other blockchains. And the reason why you want palette to interact with each other is, let's say you have a palette which define a specific type of NFT, and then you have a palette which is a marketplace for NFT. Well, you want to be able to sell your different type of NFTs on the same palette marketplace. So what you want is just for the item you send in this marketplace to implement like a tradable trait. And you don't care about what exactly is coupled with this marketplace palette, as long as it's something which is tradable and implements a trait that will allow the palette to manipulate and make the sales. Okay? Does it help?
Yeah, there is an interesting question in the chat from Elias, and this is indeed confusing when you discover the world of Substrate, because he said that why an NFT standard would be at the palette level. Isn't it supposed to be a smart contract at the applicative level? This is an interesting thing. So basically, you can still do a smart contract with Substrate. For example, there is Ink, which is a smart contract language that enables you to do some smart contract, and you can develop those smart contracts in Rust. Not something that looks like Rust, but really in Rust. We did that. We used the Ink in the internal hackathon of StarCraft to showcase autonomous smart contract, and it was very pleasant, a pleasant language to use. But you don't have to do that. And actually, it's honestly more powerful to use palettes and custom blockchain logic, because you have much more flexibility. Just to give you a concrete example. For example, let's say on the EVM, you have some kind of gas accounting, stuff like that. And actually, it adds a lot of overhead. Why? Because each opcode needs to be taken into consideration when you do the gas accounting, etc. So instead, when you do a palette, you don't have to do that. You define the features you want in the code, for example, in the transfer function of the NFT, and then you have a way to kind of price the cost of this operation in the blockchain runtime. This is called weight. We won't talk about that because this is a very specific and complex topic. But this is one advantage. You have much more flexibility. You are not tied to the execution environment. For example, on the EVM, you don't have the full flexibility. Where with Palette, you have the full flexibility. You can extend your blockchain logic as you want. Do you see the difference?
And the other difference is that in Substrate, you don't have to support smart contracts. They are like something you can add to your chain to allow users to develop their own logic, but it's not required at all. And you can have really application-specific chains which won't support anything developed by the community developer and which will just support the team which created this chain wanted to put in.
Oh yeah. So Elias put some clarification about the question. So he said, I'm asking because Madara packs the Cairo VM. So yeah, for Cairo smart contract, we don't implement obviously Cairo as Cairo smart contract as Palette. We use the Cairo VM to execute the smart contract, exactly like Moonbeam integrate an EVM to execute Ethereum smart contract on Moonbeam, exactly like Ink, for example, smart contract. This is the palette that you inject in Substrate that gives you the possibility of executing contract. But yeah, for Cairo, we obviously want to use the Cairo VM. So we have both some blockchain logic as part of this palette, like all the Starknet features, we implement them as palette. But for the execution of the dApps on Madara, we use the Cairo VM and the Blockifier to execute this application.
Yeah, Elias.
No, yes, there is a sorry, Timothy, just to add the one thing, and then I will let you go. Excuse me. You want all compute to be provable. So actually, it's an interesting question. But in Starknet architecture, actually, the sequencer does not generate the execution trace, and this is a prover that does this job and generate the proof. And it works well because it is centralized. So obviously we know that the sequencer won't generate something that is not provable. So this will be definitely a challenge in a decentralized architecture. But you have to know that in the existing architecture, the sequencer does not generate the execution trace. Or maybe generated, but the prover does not use it. I don't remember. Lucas, do you remember? At least it's not required that the prover
the sequencer generates it and the prover regenerates it.
Yeah, exactly. Okay. So, but it is not required by the prover. It regenerates it again and generate the proof. Yes, the prover packs the Cairo VM. Yeah, obviously the prover needs to be able to execute. And the whole Starknet OS is actually a Cairo program that is run. And basically, because the sequencer has access to the state and everything, but the prover does not know at all about Starknet. For example, you need to know that SHA is not Starknet aware. And actually, it's the same SHA prover that we use for Starknet, StarkX, and potentially other Cairo-based systems. And the prover is not aware of that, so he does not have access to the state, etc. So everything is memory for the prover. So it needs to execute the Starknet OS as a Cairo program that takes all input in memory. Yeah.
And one thing you mentioned, Elias, is that, yeah, in theory, because we are in a substrate chain, we could have some computation in other palettes that are not part of that are not executed in Cairo. And we could have this kind of hybrid architecture. I don't know how it will be useful, but I'm sure there will be some use case in the end that will be a little bit in the same way with Volition. We will have like provable storage and non-provable storage. We can have kind of an hybrid execution with some execution provable and some other not provable. Some custom layer 3 chain may be interested in this kind of architecture. Okay.
Just to add something, when you're for new contributors and people coming to build on Madara, you have to think of it not as you're building like your dApp or something like that, but more at the protocol level. You're really modifying the protocol itself, just like if you were working on GEF or things like that. It's a different model to have, even though like Substrate made it similar in some way to how you develop dApps with event storage and things like that. But it's not the same events, not the same storage at all. It's it's a way different way of thinking it.
Good. So I was talking about the hooks. I'm sorry, I don't have the chat at the same time, but you ping me.
Yeah, no worries, I can monitor it.
On finalize, on initialize. So what we are using right now is the on finalize, which allow us to kind of do to generate the block. Basically, at the end of each substrate block, we take the time with this on finalize hook to also generate the testnet block, which is inside. So we will like create it, emit it. Yeah, we put it in the digest. So it will be in the end, in the header, it will be added to the header of the substrate block, thanks to this. So we are creating the block and then saving it and pushing it. So that's the main idea of this architecture. So the hooks, then we have, maybe we can say a few words also about the off-chain workers, which are a way for the runtime to query data outside of the runtime. Basically, you can do like HTTP request and stuff like this from this kind of hook. So it's not a provable computation, but it can be useful sometimes. So it's basically the runtime querying the outside world and through the client. So you have to trust the client with this, because the client can intercept it, do some stuff, I guess. But it's a useful feature. I think we are using it to process the layer 1 message, I see. So yeah, this is one way. Then you define your storage. So storage, it can be values, storage value, it can be map, and there is another one which is a double map, and then there is like n map. So you can the more map you have, the more key you have until you access the value actually stored. There is another quirk. There is different hashing algorithm you can use. The more secure are more expensive. The less secure are subject to DDoS attack, but only if the external user have the choice in the key it's using. So in case the user has the choice of the key, you want to use the most secure algorithm of hashing. In case they don't, you can use a light hashing one and there won't be any problems. So the way you read it is like storage map, algorithm of hashing, the key, the value, and then there is the way you query the value. So value query, it will return the value if there isn't value behind this key, or the default value. So basically, if it's a number, it will return 0. But you can also use option query, and it will return none if there is no value stored at this place in the storage. So depending of your use case, you want to use one or the other. And in the case you are using the value query, you can also define your own default value. So it doesn't have to be 0. You can define your own default value for the storage if you need. So what we are storing here are like pending transaction, block hash, a bunch of stuff that allow us to process the block. Genesis config, it's just when you start your chain for the first time, what you want in the storage at the beginning. So maybe if we want to reboot Starknet from the previous Starknet network, one way to do this is to put the full state of the current Starknet at block n and put it in the Genesis config. Okay, so this is the function that will take the Genesis config object and then update the storage accordingly. Then we have the events. So you have the ability from your extrinsic to emit events. So you can add custom events, my events. And events, they can take type inside. So they are kind of tuple. You can also define them as a struct, like ID, value, and put like, I don't know, strings. So you can do this kind of thing also. Then there is the error. Same thing, you define your own errors. I think you can also put some values in the error if you want to. And then we arrive to the extrinsic. So there is a new macro, which is palette call. So you have like an implem block for your palette. So the palette is a type you defined up there. And you, with this macro, you said, okay, this is the type that represents the palette, which is defined by this macro. And using it, you can do implem block like this. So this, you can do multiple of those, like in regular Rust, but this one is specific because it will contain the call. It's decorated with the call macro, which means that every function you put inside will be a callable function. So it will become an extrinsic that can be called by users of your blockchain. It has a weight associated with it. So another thing for people who came from the Ethereum virtual machine, the way the cost of execution is calculated on Ethereum is that there is a cost for each opcode you are using. And the more you use them, the more you pay. In Substrate, it's the developers of the blockchain that choose the price of each extrinsic. Like this one is free to call, but if I want, I can put it at 100 and it will cost 100 of whatever we decide to pay with. And we can do like more complex function. Like if here I have an argument, which is like a number, and let's say this number will be like the number of iterations. There is a loop which is based on this number. I can take it in account in my weight, and the bigger this number, the more expensive it will be. Or if I have a vec of something, I can take the length of this vec into account in order to calculate the actual weight the user will have to pay. And the way we do this, we decide how much the user should do is that we use like the standard machine, as we talked before, and we run like tons and tons of extrinsic, and we measure how much time, how much computational resource it takes on a standard machine. And there is like a script that will output a default value for those kind of things. So it's kind of balanced based on the actual computation is did. So you have to go with, you have to test for the worst case scenario when you are doing this kind of benchmark. But you can also say it costs nothing, or you can say it costs twice as much as what it was supposed to cost. Like you are really free to do whatever you want with it.
And it's important to consider that we won't use this system because the pricing of operation will be determined by the blockifier or Starknet in Rust. So we cannot use this system. This is why we put 0, and the pricing will the handling of the fees will be done separately. Yeah.
Yep. So now let's look at what is inside a basic extrinsic. Most of the time there is like, so they all have to have first argument is the origin. So is who is actually calling this extrinsic. So it can be sign extrinsic, so it's somebody is calling, or there is case where your runtime can call itself and it's unsigned extrinsic. So what we want to do there is like make sure that the color is signed. So we do a bunch of checks. We ensure that the arguments that are passed are valid and it won't cause any trouble. Then we modify the storage. So this is a storage which has been defined earlier. So it stores a value. It stores bounded vec. Okay, so it stores a vec of transaction, and we append a new value to this storage. And then we, once we updated the storage, we deposit the event to explain what we did and what was the outcome of this call. Basically, it's like the core architecture, the core thing you will see in each and every extrinsic.
Yes, exactly. We can go through this one, which is more interesting. And by the way, in the first one, the ping one, we did a signature verification. But actually, for we won't do any signature verification in the meaning of substrate context. So, for example, in invoke, declare, deploy account extrinsic, sorry, there is no signature verification in the meaning of substrate terminology. Why? Because we have account abstraction. So we use only unsigned extrinsic sorry, on Madara. And because, yeah, we have account abstraction, so we cannot use that.
Yep. So basically, that's how it works. And so here are all the call. And there you can see there is another implement for palette, which kind of add a useful method for the palette, but are not extrinsic because there is not the macro call. It's just like if you want to reuse code that is generic over this palette, you have to put it there. And you can make the choice to make it public or private. The thing is, if you make it public and another palette end up using your palette like in a hardly coupled way, it will be able to access to every public function defined on this type. So it's not like a user can you see maybe a user, if you have smart contract enabled and they can interact with it, can do like messy shit. So you have to be sure about what you're exposing, that it's not like arbitrary methods without checked. Like if your method doesn't implement any checked, it better be private so that not everybody can use it from outside. But it's not like everybody can just call it. It's more like other developers using your palette, interacting with it in their runtime can mess up things. So yeah, that's basically how it works. And now the question is, how do we do RPC for this? That was like my main thing. So the RPC, it actually doesn't happen in the runtime itself. It happens in the client. So there is a RPC server which is run by the client. Yeah, perfect. I have it here up. If I go, yeah, new partial. So basically, when you run the client, it will set up like all the tasks it has to run in the background to do like telemetry, executor, managing the storage, transaction pool. Yeah, this is consensus stuff. And this is our Madara backend. So it's a database we are using. And at some point, I'm spawning a RPC server. I don't know, it's not here. Well, we will find it later. So the architecture I chose for the crate is that everything I did was highly inspired by the Frontier project, which is the same thing we are doing, but for Ethereum. So they are bundling Ethereum virtual machine blocks inside the substrate chain. So we are basically doing the same, but with two different virtual machines. So the core, like the core method where we define the StarkNet RPC API is here. So the StarkNet defined like its RPC server using OpenRPC, which is like a way of writing JSON that represent an RPC server. And in theory, we should be able to use it to automatically generate code, but the problem is that they did it in a really poor way, so it's not usable. You have to rewrite the different.
Don't forget that the code is recorded.
Sorry, guys.
No, but it's true. The StarkNet API is not really compatible with OpenRPC specification, which is an issue.
But Paul-Henri, which is in this call, is the contributor working on it. He started today, I believe. So it will be fixed soon, thanks to him. So what I did right now, yeah, Paul-Henri, maybe you want to talk?
Yeah.
You always want to talk. Yeah.
No.
no, I'm joking. Yeah, go ahead. Feel free. It's good. Very good.
Yeah, so I took this issue about OpenRPC compatibility because we are trying to generate types from the OpenRPC, but the problem is that it's multiple things. Firstly, just the RPC specifications that were created are pretty old. So I think it's the last version we used is like 1.0.0-RC. It's like a version from 2019. So it's pretty old. So the specifications are not really up to date anymore. And the way it was built, I think it has been built by different people, because you see that the way they build it is not the same at many points. So sometimes they use titles, sometimes they use summary, sometimes they use description. And so just basically it breaks. So when you build the types, it's not functional. So you're just not able to generate any like generated code. So so this is problematic. So I think I would be potentially able to fix it. I'm not sure yet because I spent like 4 or 5 hours this morning like working on it. And one problem is that like with what we have right now, just the generation doesn't work. And so one of my feelings is that potentially we will not be able to just fix it like that. We'll need maybe to restart and like rebuild a little bit from scratch the API document, like the OpenRPC API of StarkNet. So this is potentially what we will have to do if we want to use like automatic generation of code.
Okay, so it was worse that one we thought, but I think, Abdel, that there is a new RPC version coming. Like the RPC method are evolving. I saw like, I think I saw an issue like this. So maybe like having the new version of the RPC methods standard can be the opportunity to like burn everything and start done properly. Maybe we will have this call, this discussion later, but it may be a way. So what I did is that I coded those types, I added them, and I just put 3 RPC methods from now. So this is a macro from JSON RPC, which allow you to basically derive an entire RPC server just from a few method definition. So right now we have block number, block hash and number, and get block transaction count. Then what we do, so this was RPC core, so it's for the Madara client, like the core RPC. So then what we have is that we create like here we are just defining the traits. Here is the file from Starkware defining like the RPC schema, if you want to get to have a look at it. So this in this RPC crate, we are actually defining like our StarkNet backend and what it need to serve those requests. So really easy. So we define this structure. It contains the client. So it's like the whole Madara clients, the backend, which is just it's the backend of our Madara database, and overrides, which I will talk about it a bit later. So then we can implement method on these clients that will be useful to like query the actual data we need. And the way we do this is that here is me writing like, how do I get the current block? What I can just do is call self client. So it's the Madara client, and it already has some info, and best number is the number of the current block. So I can just return this. So this one is really simple. I kind of already have the answer in the client. I just have to format it. There is more hairy thing. An example is the current block hash. The idea is that because we are using substrate block, if I here for the number, we are lucky in a way because there is a 1-1 equivalent between substrate block and starknet block, which are the wrapped block. So they start at 0 at the same time, and they are produced at the same rhythm. So they all have the same number. So what
this is not just this won't be the case if we
if we start with an existing state. Exactly, that's what I wanted to say. Yeah, so we need to do the same technique as the broadcast. Exactly.
Okay, good. So this won't work because here what I'm reading actually is the number of the substrate block. But if I want the hash, like in the starknet RPC client, when user asks me for an hash, what they want is not the hash of the substrate block, they want the hash of the starknet block. Yeah. So I have to find this hash, and this hash, it's stored in the block, which is stored in the storage of the runtime. We have a storage which is current block hash. No, we have a storage which is block hash, which store the hash of the last validated block.
That's current block here as well.
No, there is a mapping. Block hash is a mapping of block hash block number, and current block is the actual block that has been produced. Yeah.
Oh yeah. So in current block, which is just a value, there is like a starknet block, and this contain like the header of the blocks right now. And in the header, I can find the block number and the parent block hash.
No, you have a function to call the hash.
There is a function, yeah, which implements
to compute the hash. Sorry. Yeah.
How do I move this? It's on my way. Sorry. Oh, here. Okay. Zoom getting on the way of my mouse. So we have to query like the storage in order to find out like what is actually stored inside the storage, and get this block so we can compute the hash. So here we end up with the override. Basically, there is two ways of doing this. The first one is to use what is called in Substrate the runtime API, which is kind of an interface for the client to do call to the storage, but calls that won't mutate the runtime. So call to the runtime that won't mutate the storage. So you can read from the storage, you can process the data, you can do a bunch of things. And but it should be like in Starknet, it should be call, not what's the name in Starknet? There's calls that don't mutate the storage.
View functions, but it's not enforced. But
okay, so it's kind of the same idea, and we can see an example. This. No, we cannot see. So here there will be at the top of this block. Yeah, here there is like a function which is a block timestamp, and it will allow you to read from the storage this value or current block hash. This is like pure example of it. It's exposed on the palette, and it just reads the storage and do some computation. So it reads the block, take its header, and calls the hash function. So this is callable from the runtime, from inside the runtime, but it's also public. And the thing is, when you define your runtime, you have to implement each and every you have like a runtime API which is defined there. Okay, let's go to this. So here it's in palette testnet. Yeah, I put it in a different file, but it's runtime API. So this is a macro from Substrate, which allow you to declare like an API for your runtime. So you put on like a trait, a few function, and then when you are actually setting up your runtime, so you are defining your chain and you are adding like all the palette you want to the actual chain you want to run. So you are putting them all together, wiring one with each other. You also have the responsibility to provide implementation for those runtime API, which are defined for the palette you are using. And so what we do there is that here we have like the palette runtime, so testnet. It's the type of our palette testnet. And what we do is that we will use the method we saw just before, which is public, so it's exposed, to call the runtime and do the computation. So it's kind of a bit complicated. So I will sum it up. Like each palette can define a runtime API, which is an interface for things that are outside the runtime to do call in the runtime of this palette. And when you are building your actual blockchain, you have to specify the implementation for this API, and you can use in this specification methods that are public on the palette. So that's what we are doing here. Okay, any question on this? Because it's a bit hairy. It's not really nice. Is everything okay with what I said? You got it?
Yes.
Yep.
Okay. So the problem with this is that it's kind of heavy because we have to switch from the regular client computation, like client execution, to the WebAssembly runtime. And the runtime it's not just like you saw there is a lot of macros. So when we are actually calling these functions, there is other things happening. Like there is a lot of boilerplate in a way. And when the only thing we want is to like read something from the storage, it's kind of expensive to switch the execution to the WebAssembly runtime, call its method, do all those kind of stuff. You have to spin it up. Like it's a lot of expense. So there is a better way, which is you can, if you know what the storage look like, you can just index directly into the database, the storage itself, and go get your value. Okay.
Yes, I agree that there is an overhead, but honestly, I think this is still the best solution. Why? Because it's more flexible and less risky than relying on the storage structure. And also because actually you don't really, it's not that you don't care, but for RPC interaction, they don't have an impact on your actual blockchain, because you can have a node that is just an RPC serving the need of the user that want it. Ideally, this is what you want. If all users have a full node, it doesn't matter actually. It's fine to have this over. So yeah.
So the way overrides work is that first they will try to read in the storage directly, And if this fail, they will query the runtime.
Oh, nice. Okay, nice.
There is a fallback. So first you can just read the raw database, and if you are happy with what you found, it's nice. But because it's failable, you can fall back to calling the runtime API, which is not supposed to fail, because if this method fail, like basically is that there is something wicked with your chain itself, and it will fail somewhere else.
Interesting.
This was in Frontier, so I took it, and it's working. So if we go back to my RPC implementation, that's what I'm doing there. I'm getting from my my StarkNet backend, I'm getting my override, and I get, like, because we have runtime upgrade, the storage can be upgraded too and change. So what we want is a storage layer at a specific block. So we are using the substrate block hash to say that we want the storage as it was for this specific block. Because we are using like current block hash, we can take the best hash. We use this current block and we query. Yeah, we get the current block. Yeah, and we query like the method current block, which I implemented on the storage override. So, and we get like the block, and then we can return like the header hash method. So basically, we read it directly from the storage rather than going through the runtime, except if we fail in the first case. So this is nice, it worked well. But if we go to the next one, which is get blocked transaction count, we will have more problems. Because in the StarkNet RPC, the user, they query the RPC method using block ID. What is a StarkNet block ID? It's an enum, which is either a block hash, a block number, or a tag. Tag, it's latest or pending. So this way you can query like the same thing, but in different way, depending on if you have the block number, the block hash, or if you just want the last block. The problem is that in order to read the storage, to index the storage, or even to query the runtime, I want to query it at a specific block, which is the block which has been passed as an argument. The problem is that this block hash, because, well, if the block number are the same, it's okay. But we saw that it won't necessarily be, so we will have to change that. But in case of the block hash, the substrate block hash and the StarkNet block hash are both different. So if here the user will send me like the StarkNet block hash, and the only way I can query the storage is using the substrate block hash. So I have to retrieve the substrate block hash, which is linked to the StarkNet block hash. The problem is that I have no easy way to do it. Like I would have to do like a query one by one, looking at each substrate block and looking inside to find the one which has the StarkNet block hash I want. So this is like a log of n, no, it's n complexity, so it's really stuck. So what we did is we created like a kind of reverse caching, a mapping, which will map from substrate hash to StarkNet, from StarkNet hash to substrate hash. So the way it works is that the client, each time a new block is finalized, it will listen to it and it will manage its own little database in the corner of the client where it will keep its mapping. And then when somebody call for a specific substrate, a StarkNet block, we will be able to retrieve it from this, this mapping database and take the substrate block which is linked, and then do the same thing we did before, just here, once we have the substrate block hash. Okay. So the way we did this is in this crate mapping sync, which map the StarkNet to substrate block. No, oh no, actually no, it's there. It's in the database. So here is the definition of the database.
There is a question from the chat about the migration from an existing state. So we thought that it would be problematic about the correlation between substrate block number and StarkNet block number, but it won't be problematic for this mapping because it's a mapping from StarkNet block hash to substrate block hash. So we won't have any issue, even if we start from an existing state. Yeah.
Yep, totally. So this database is quite simple. There is like the mapping database and there is meta, which meta is just store data about like the last block we indexed, like the last block we saw and we mapped. And the mapping, it contains basically items that are like for each StarkNet block hash, it will store a substrate block hash. Let's keep it simple. And then there is this mapping sync trait, which implement a stream. So basically, it will listen to the flow of new finalized block. And when one is finalized, it will update the database accordingly. So here is like the logic. Yeah. So that's basically how it works, and it allows the RPC client to easily do the reverse indexing and then be able to query through the override, like the storage, to know what's inside. So this work, I can make it run. Oh, I changed stuff. Nothing important. No.
And implementing RPC will actually something be very interesting for new contributors, I think. Once Timothy merged this year, there will be all kinds of different.
We are in. It's merged. We are in main.
Okay. Since when?
Oh well, 1 week probably.
Oh, this is this one because I thought this part was new. Actually, because it mentioned some the frontier and its stuff. So, and there is not this part in. Oh yes. So okay. So it's.
There has been some
yeah.
It was merged.
No, but okay, but there is still some typo in it. I will fix it because there is a mention of its block hash and etc.
Okay.
Which is actually a StarkNet block hash. But anyway, okay, sounds good. So yeah, it will be good first issues for contributors implementing a new RPC.
Yeah, because now we have like the basic architecture, and there is just to add more method. And I think there will be some challenge along the way, and we will have to find some innovative way to read from the storage. But the main architecture, like having the reverse mapping, being able to read from the storage with override or the runtime runtime API itself, and then return it to like the color, this will work. And I think a last thing that will need to be implemented at some point is some form of caching, LRU, probably, in order to optimize the performance if a lot of people call a node, but there is no here, but it could be. So here I will be calling like the StarkNet block hash and number method, RPC method. So I get the StarkNet block hash, not the substrate one, and the block number, which is 16. So we will have like a little, yeah, it's this one. And now what I can do is use this block hash to curl, let's say, the other one, which was get block transaction count. So what I can do is call like latest. I will have the number block not found. Okay, this doesn't work. Good to know. But with the hash, it worked, and it tells us that there was no transaction at all at this in this block. So I did the test before where I added transaction and it was returned as a good value. But the interesting thing is that this is the startnet, is the hash of the startnet block, and still it's able to process and give us a result because it synced the block and did the mapping previously. So yeah, basically that's it. That's it for the RPC client and how it does work. And I will be available for anybody that want to contribute on it, like to help.
Nice, very nice. Yeah, as I said, those are very, very good in terms of first contributions, because this is it reminds me of the first contribution in Kakarot and Virus. Like in Kakarot, it was we have set up the architecture, and then people were jumping to add more opcodes. And on Virus, it was the same. We implemented the first architecture and the first RPC, and then people were able to take inspiration and add more RPC. So it's the same here. And as Timothée said, he is available for help. So feel free to definitely take some RPC. And yeah.
Yeah, the objective is full coverage of what is defined in the OpenRPC Starkware document.
Yes, exactly. So I don't know how many RPCs there are, but there is 13 participants here. So each one of them take one. It can be fast. Yeah. Okay. So yeah, thank you very much, Timothée, for this very interesting deep dive. It will definitely be a very good material for new contributors. Yeah. So if anyone wants to add anything or ask any question, feel free. And is there any question, any comment? No? Then yes, I guess we can stop there. And thank you very much for your attendance to this third community call, and see you next week for the next one.
Thank you, guys.
Thank you. Bye-bye.
Bye-bye.
Thanks. Bye.
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 Bye, guys. See you.
Timothée.